Hey everyone, today we will be talking about USD asset resolvers. So just a small disclaimer up ahead, this video won't be about a high-level overview of what asset resolvers are in the context of USD. Instead, we'll be focusing on how you can build your own asset resolver with the reference implementations we ship as part of the USD Survival Guide. If you need a high-level overview, we highly recommend reading the Pixar documentation itself or also checking out the UsdAssetResolver section in the USD Survival Guide. So if you go to the page here and scroll down a bit, you can find a link to the GitHub repository. And yeah, what we're going to look at in today's video is the content of this repository and how to work with it. So let's first look at a brief outline of what we're going to talk about. So first off, we're going to cover the installation. We currently offer 3 different installation methods. The first one is installing via the automatic update manager. Since the repo is and also the guide is heavily Houdini oriented at the moment, the update manager currently also only works for Houdini. It offers a one-click install basically of different resolver types that are in the repo, and it's perfect if you kind of want to get your hands dirty and play around with resolvers and how they work as fast as possible. Then the next installation method is just using the build scripts. They wrap a bit of the logic to make it easier to install the content of the repo. And last up, we're going to look at the, let's call it, traditional building method of just using CMake. After we have it installed, we're going to talk about how you can test your implementation or when you start to customize it, and we're also going to show a practical demonstration of 1 or 2 resolvers that are in the repo. Cool, so let's get started. First up, let's take a look at the automatic installation method. So to launch the automatic install, what you can do is go to the automatic installation page of the AssetResolver documentation, either by clicking any of these links on the main page or going to the documentation link up here on the top right of the repo and then browsing to the automatic installation section. We're going to cover the content of this page in this video right now, so let's get started. So all you have to do is copy this snippet right here and launch a recent version of Houdini. Alternatively, the link is also on our main page here. If we have copied the link, then we just need to go to Windows, Python source editor, paste in the link, and then it will load a bit, and then it will show us in dialog what version and what resolver of the resolver's implementation in the repo we want to install. So it opened up now. Let me change the folder real quick, otherwise you can also browse to the folder. Here you can switch between different release versions. I recommend always sticking to the latest one, and here you can select what resolver you want to install. Let's just stick to the defaults and click install. That's it. You will be informed that it installed in that directory, and then you can just close Houdini. If you want to install different versions, and you can also just run this installer twice, and then it will have everything grayed out, show you the location, and then you can uninstall or change the release. After we have installed, we need to close our application, and since USD plugins depend on some environment variables, we have to launch Houdini in a bit different way as usual. So you have to browse to the location where you installed the resolver, and in there you will find a launch.sh or on Windows a launch.bat file. In this launch file, there is nothing scary. It only sets a couple of environment variables that are needed, also debugging, so we get some logs if everything is working correctly, and then it just launches Houdini. All right, so when we're done, again on Windows, just double click it or run the file. Same on Linux, right click, run as program, or double click. So I'm gonna do that. Then we get our terminal. And as you can see, there are debug prints. On Windows, you'll likely get a pop-up on the bottom right that has the exact same content, and it will show you that the resolver, the one you chose in the dialog, is loaded. And that's it, simple as that. Now, if you don't want to use the automatic installation method, but still use the precompiled binaries, you can go to the release page here and just manually download the release matching your Houdini version. And then you have to basically set up the environment variables yourself. So this is described in this section here, again, in the installation, and then here you have the environment variables. So all the launcher does, or the update manager does, is set this up all for you with the Houdini version you just started. Next up, let's take a look at using our build scripts that are part of the repo. So they are, again, also available for Linux and Windows, but on Windows you will need, of course, have to install all the Visual Studio compiler and build tools. So make sure you have done that. Again, that is also documented on the installation page of the docs. So if you go to the requirements, you'll see what you need to download. All right, so what you need to do is download this repo and then jump into your favorite IDE, open up a terminal. Let me open up a new one, and then let's see what we have. So what you can do is either directly run these build.sh or build.bat scripts if you are on Windows. For Linux, we also have the setup.sh script. So what this does is, on one hand, set the necessary variables that the build.sh and build.bat depend on, and it also sets up all the environment variables so that later on, if you start Houdini from the same shell, it will already have the USD plugin loaded and you don't need to configure that. This is ideal for testing, but again, you can also just launch these directly. So if you want to use the setup.sh script, you just do source setup.sh, then it will tell you which resolver was initialized, which Houdini version was loaded, and then you just need to run build.sh. Now, if I don't want to run the source script, let me restart with a new terminal. The setup script, we can also either set the environment variables beforehand, what resolver we want to compile, or we can uncomment these lines, point this to our Houdini install directory and this to the resolver name that you want to compile, and then you're ready to go. So if I uncomment, let's take a look at our third option now. So our third option is to use either use CMake commands directly, which also the build scripts do, or you can also do the setup with CMake GUI. So I've opened it right here. And yeah, all you need to do is kind of check what resolvers you want to compile. With the build scripts, it's always only one resolver at a time. With CMake GUI or just regular CMake, you can also configure multiple of these to compile after another in the same run. So all you need to do, again, is specify the Houdini directory, and then you're kind of good to go. So let's just click configure. Let's click yes. And then it will also print out what environment variables you should set after the compilation to make the plugin load. Again, this is also documented in the documentation. And then generate, and then you're good to go. And then you can just run these commands as you usually would. So if I do this now, at this point, a small sidebar. So if we take at the main CMake lists text file in the repo, you will see that not everything is exposed to be available in the CMake GUI. This is kind of on purpose. This might be refactored at some point. So currently we only expose the Houdini install path and how you want to name your environment variables, which are important for some of the resolvers in the repository. If you want to customize more, you can do all of this here. Basically, in this section on top where it says configuration, you can customize naming stuff, again, which resolvers you want to compile, and yeah, where to find files. Again, this is all kind of built against Houdini, but it is very easy to customize it against other DCCs or standalone USD2. Basically, you just have to reroute where to find the compiled libraries and headers, and then you are ready to go. After you've installed the precompiled binaries, or if you compiled it yourself, you are kind of ready to go and you can start customizing the resolvers. We have a bunch of different resolvers, so this is kind of different per resolver. Again, if you go to the documentation, you will find an overview of each resolver and also how to interact with it, because they have different stuff exposed to Python. What we're gonna take a look at first is customizing the CachedResolver. So the CachedResolver is kind of a C++ Python hybrid, and it should give you the benefit of C++ speeds and also benefit of easily adjusting something via Python. This is ideal for smaller studios who don't have the resources to even self-compile resolvers, but still need to kind of make adjustments. So let's dive right in and take a look at that, how it works. So I've installed it as seen earlier via the automatic installer. And what this does, again, the launcher sets the environment needed to load this plugin file and also the libraries. And if you go into the directories here of the CachedResolver, you will find a Python expose file. Now you can put this Python file anywhere on your system path or Python path. It just has to be found, and then the stuff in there will be run. Let's take a look in our source repo where it is. So let's browse here. Again, you would be editing this in your compile directory or in the installation directory if you use the automatic install. So I can just as easily open this file. Now the CachedResolver basically only calls Python when it first finds a non-file path file. With that I mean a path that doesn't start with slash or dot slash, so no relative paths or no absolute paths. So anything basically that is a identifier and not a file system file path will be run through these methods that we see here. So the important one is the resolve and cache. So anything you pass through here, what you get as arguments is the asset path and the context. And yeah, anything that is resolved in your stage gets passed through here, and then you can modify it. So the stuff you see here is actually needed for the tests, which we'll be talking later in this video about. So if you want to actually customize, all you have to do is just delete all of this. And basically it's these two lines, all you need to do. Now add your custom logic here, and then yeah, redirect the identifiers to your files on disk in the way that your pipeline expects it to. If we have adjusted it here, then we just have to relaunch Houdini or the application we compiled against, and everything should work as expected. Since this resolver is called CachedResolver, we have to add, or we of course should always add, so it doesn't run this method multiple times with the same path. We should always add it, our paths to the context which holds all our cache data. Again, we're not going to go into specifics. This is all documented in the documentation. So if you go here, CachedResolver, there's a lengthy explanation of what it does, and there are also plenty of code examples of the whole functionality. Of course, you can also add multiple paths right here. So a typical setup would be that, for example, you load up all the assets up front, then everything is cached, and then it just does the lookup in C++. You can either do it here when it, for the first time, finds an identifier that is not a file path, or you can also do it in initialize. Initialize is called every time a context is created, which is basically every time a stage is opened. If the stage doesn't receive a custom context. Now, if this was too kind of still abstract, let's actually take a look at a very, let's say, simple implementation. So on initialize, we're just adding a identifier cylinder and some absolute file path, which is part of this repo. And for the resolve and cache, we do the exact same thing. So if we launch our application again, as discussed earlier, then we will get something like this when we start up. So here you can see that the initialize method was called because it is initializing the default context, and it successfully added this pair right here. and nothing else is printed. So let's then actually dive into our application. Let's go to the stage here and just add a sublayer node. And if we now let me rearrange the windows here a bit. And if we now just type in our identifier that we added, so if we type in cylinder A, and then just load our stage here, you will see that it actually loaded this file. So if I browse to this file, we get the exact same file that is now loaded. So everything works. And as you can also see by this example, since we initialized it, it's actually not running through the resolve and cache function. So what happens if we add an identifier that is not cached yet inside this cached dictionary? So let's try entering the box now. And let's cook the node. And as you can see, it now triggered this resolve and cache function. And again, if we display our stage, you now have a cube, and that's the content of this file if we browse over here. All right, that's all good and working. And to again verify that this is cached, let's go here and reload and recook the stage. And as you can see, the Python function is not called twice. So everything works as expected, and you're kind of good to go. Now, one small thing to note is that if you have a syntax error in this file, you might not notice when you type out the file until you launch it. So what happens if we do have an error? So what the error message will be something like this. You'll just get a Python exception, but you actually won't have the specific error because it is currently not passed through. We might make this more verbose in the future, but yeah, just a heads up, make sure your code is actually valid. For all R&D and production resolvers in the repo, we actually ship unit tests. So these are a great way to actually test at compile or post-compile if everything works correctly. It is also a good resource to kind of check how the API of the resolver is supposed to work. So again, just browse to the resolver you're working with, and then you have this test end folder and the test. And again, these are available for all R&D and production resolvers. So another interesting resolver is the PythonResolver. So should you use this one in production? Probably not. You should rather use the CachedResolver. But why is the PythonResolver of interest to us then? So the idea behind the PythonResolver was that it can be used as a pure R&D resolver, where you can just check out how asset resolvers work in general. And if you don't have the developer resources for a C++ developer, you can basically write the whole thing in Python and then just tell someone to write it in C++, and you kind of have your finished product. So that was kind of the idea behind creating this one. Again, as with the CachedResolver, you have this Python expose file. It just needs to be anywhere on your Python path, and then this gets called. And the PythonResolver is basically every single or almost every method of the resolver is exposed to Python. And if we go into the Python expose file, what the Python resolver actually is doing here, like this reference implementation of it, is actually the same as the file resolver. So you kind of have a match in functionality, and you can kind of check what the file resolver is doing, but everything in Python. If you want to enable logging, you just need to go to this log function up here. It's attached everywhere down in the file as a decorator. So if you just re-enable that, it is usually commented out. You will get a bunch of logs and you can kind of see what is happening. This is a bit verbose because it is printing the whole context, but you can see this is just the regular log of opening up Houdini without any plugins or files loaded. You can see it is loading a lot of Houdini files that are related to Houdini. So again, this is for debugging. It's a great tool, or to build a concept resolver, and then you can rebuild it yourself in C++ or outsource it. That was kind of the idea behind it. Up here we have a bunch of methods. Again, these are the same as in the file resolver. Resolve C++ file, and then we have all the resolver functions and the resolver context. It is a bit different than the file resolver because the whole context is just a serialized JSON dict, and on the file resolver we serialize it to C++, like maps or arrays. So that part is a tiny bit different, but functionality-wise it is on par. So it is an example of how you can go from a Python-based resolver to a production-ready C++ resolver. In this case, we called it file resolver. Now for the Python and file resolver, there are also a couple of test files you can play around with. Again, this is all documented in the documentation. We'll quickly just show you visually how to do this. So if you've compiled the resolver, and if you've also used the setup as H script, this will already configure all the testing variables. If you use the quick install, it won't. So what you need to do is add the following to your environment before you launch Houdini. And yeah, all this does is set the search path to this folder, and then it tells it to map anything that starts or is with the letters BO to capital BO. And let's see how that works. So if we then just put in our file, which is called box.usda, it loads a box. And if we want to map that file to anything else, since the file resolver uses these environment variables to perform a regex format, so it matches the string, in our case box in lowercase, so it will match these two letters, and then it will format them to this. And then in our mapping file, it will perform a lookup, and if it finds the formatted string, which is in our case box.usda, it will try to map it to cylinder. So if you installed and set all the environment variables correctly, and you set a mapping file as seen here, what should happen is that the box gets swapped to a cylinder. So if I unmute this node, you can see it works correctly. In Houdini, you can set the context in two ways. So either a configure stage node, and the leftmost node in your tree will always have the higher loading order if you would try to set this on multiple nodes. It also has to be the first node in the stream. The other way, if I mute this, is you go to your stage context and then pick the file here. So if I copy that file and again go here and paste that in, you will see it also gets swapped to a cylinder. Again, we do have unit tests for everything, so if you need to have more practical examples, read the documentation or check out the different resolver unit tests. Now, before we wrap up, we just wanted to mention that some resolvers do have some more dependencies that you kind of need to set up before you test them. So currently this is the HTTP resolver that does this or has this, and I've installed it via the quick install. And again, I have my launch file, but here I also have this demo file. So just be sure to check out the documentation and I'll just run you through this test case. So all you have to do now is launch the install script. Very important here, make sure you launch it in the directory where the script is and not somewhere else, because it should put the virtual environment here. It will set up a Python virtual environment with the necessary package, and then you can just run it and then run the server install, and then it will locally run the test server, and then as normal with all the other resolvers, you can just start the resolver and it will work. That wraps up this video. Thanks for watching. If you have any questions, you can add them in the comments below or file a GitHub issue. If you stumble upon any other interesting resolvers, I'd be happy to get in contact with the developer and add them to this repo so you can play around with them. If you are from another software vendor and you would like to see this resolver also get, or these resolver examples also get auto-compiled against your DCC so people can play around with them, please get in contact with me. It would be a pleasure to also add them there. Thanks for watching and see you next time.